Okay, so I know we're a small group today, but we'll go ahead and record this so that we have it available for future residents. And today I have the pleasure of introducing Drew Winters, who is one of the current second year DPRG postdocs and is a very big proponent of R, as he was just discussing with Susan, and is going to talk. It's an open source free platform for statistical analyses with a lot that's available programming wise. And Drew is going to give us a whirlwind tour through R as a platform.
Yeah, I'm going to share my screen. Thank you, Joe. All right. Thanks. All right, yeah, great. Everybody see the screen? See the screen, Joe? Yeah, okay. All right, well, thank you for introducing Joe. I'm excited to be presenting to you today R and to talk about it, but today will be in no way a comprehensive view of R, but rather an initial introduction that can get you started. And I'll provide some additional resources that can keep you going. My goal for the session today is that you will get a sense for how R may be useful and that you'll leave with a basic understanding of R and how to use it. And you'll be interested enough to continue learning R. We will cover some basics in R, and unless you are already interested in computer programming languages, it may not be initially engaging to you. And while I apologize for this in advance, it is important information to set you up for starting to use R on your own. You'll start by exploring why you may want to use R, kind of sell it a little bit, and then give some strengths and weaknesses, and then sort of orient to RStudio before we go into a tutorial on R. So to start off with, what is R and how can it be useful for you? R is a functional programming language for statistical computing and graphics. It is widely used by professionals from diverse disciplines to estimate and display statistical results. And the benefit of using R over other languages is it uses objects, which makes things much easier to refer to and often prevents having to write longer lines of code called loops. And we'll get into objects during the tutorial. Now, R can handle any data science or statistical components of a project you need, from analysis to dissemination. For example, the slides I'm using now were created in R, and this makes R a useful tool for any research project. Now, R has become a front runner for statistics. On the left, you'll see a really dorky meme depicting SPSS and its downfall in 2009, which is the point at which SPSS saw a drastic steep decline in use ever since. And on the right, you'll find results of a poll on who is using what statistical software. And as you can see at the top, R is leaps and bounds above other statistical packages such as SPSS, SAS, Stata, and others. So the strengths of R are that it is free and open source, meaning it is freely available to anyone. And this is positive to you because it's of no cost and it's easy to obtain code from others or share your code with others and learn in those ways. For science, R is a common platform that all have access to without paywall barriers. And this can speed up the progress of science by greater accessibility to your analyses. And you can test the same analyses on new machines to look at reproducibility or easier application of your code by other labs to new samples to replicate your data, replicability on new data. Sorry. You have access to cutting edge statistical methods. R can handle anything from simple descriptive statistics to advanced statistical methodologies, making a useful tool for any project. And when someone develops a new method anymore, this usually centers around the development of an R package that you can use. And if there's not an R package available, R is flexible enough to run new methods. Now, R has a strong and supportive community. The support from the R community can answer about anything you would need just by doing a quick search on the web. And there are over 10,000 packages created by the R community to help make your analyses easier. And to demonstrate this is a graph. This figure depicts the number of questions and answers on topics related to given statistical software and language on popular sites for stats questions, including cross-validated and talk stats. R is at the top. And as you can see, there are several orders of magnitude above all other listed software. And this indicates that there is an active community where questions are being answered that you have access to, or you can ask your own questions and it'll likely receive answers because there's an active community. Now, there are some difficulties to consider. First, learning a new language takes time and effort, and this can be a bit of a steep learning curve, to be quite honest. But I argue that the return on investment is well worth your time. You'll gain a translatable skill that will benefit multiple aspects of your career, and you'll gain a deeper understanding of your statistical analyses, which will improve your use of statistics and communication of your science. So while initially cumbersome, it's in my experience that it's well worth your time. Now, first, I want to orient you to what you'll see before we go into tutorial. This can be overwhelming with a lot of different screens and buttons to push, so I hope to tame that a little bit by orienting you here before I demo the functionality of R. So when you open RStudio, you'll see a window with four separate panes in the window that look like this. And here's the first pane in the upper left. Pane 1 is called the source pane. This is like a notepad for your code, where you create a script that you can save for later work on the same project or come back and edit it for a new project. And you can take that file created and share it with other scientists so they can also use your code. And if you end up opening the code that I provided for the talk here, it will open in this window and you can follow along. Pane 2 in the lower left is where code results are displayed. You can also run live code here that will be evaluated immediately. And I want to just mention that code that you run here is not saved. It is immediately evaluated after you press enter and it is not saved. So if you run something here and you want to save it for later, you're going to want to copy and paste it to the source pane, pane number 1, so that you can keep it. Pane 3 is the environment and history window. Now this lists the objects you create in your current R environment, and we'll get to objects during the tutorial, as well as a history of the commands that you run in your current session. And then pane 4 is where you can look to see the plots you create, what packages that you have open, and if you use some of the help functions to see, we'll get into some of the help functions as well during the tutorial. It'll come up here with help on how to run different commands. All right, so that's the intro to that. Let's go ahead and dig into R and get a sense for some basic functionality of R. Now, Susan, do you see the R window? Okay. All right, so when you open R, you should see something like this. A couple things I want to mention is that my R will look different than yours. First of which, mine is in a dark background. So I hope that's okay for everybody who's viewing. I prefer it. It's easier on my eyes, and you can change yours as well if you'd like to. If you go into the tools up here, down to global options, and you have a number of options here. I may have a couple of different options in you, but you will definitely have appearance and pane layout. So appearance, you're welcome to click on any of these and you can preview them here on what you may want. I like Cobalt, it's my favorite. You can choose another one. You can also increase the font size. And I'll just ask if anybody wants me to increase the font size of my R. Yes, Susan does. Let's try 14. We'll apply that. Okay, is that better? Yes, good. So you're welcome to do that and change it just as easy as that. One other difference that you will notice for mine than what the standard layout is I switched these two pane. Oh, let me open these up for you. I switched pane 2 and pane 3 that we showed in the demo. And the reason for that is it's much easier for me to demo R where I can run code here and it's immediately evaluated over here instead of having to look down here at this window. I also prefer it this way. You're welcome to change that as well if you go into the tools global option, pane layout. You can see source window, console window. You can just point and click and drop down what window you want where. It's fairly easy to modify, but I did this to make it easier for us as we could do the demo. So this is where my environment window is. I don't look at that too much. The console window up here, and then the plots and the help files are all down here. We'll see that here in a minute. Okay. One other thing I want to mention, you'll notice that I have a lot of these pound signs throughout the code here. And what that does is it signifies to R that do not run anything that's after this code, or that's after this pound sign. This is not code, this is just a sentence. So if I were to uncomment it, it'll come up with an error because that's not code that R recognizes. So I want to keep that commented, and this allows me to make notes in my code. And I'm sure that you also find these very helpful as you use R to comment to yourself what you're doing in your analyses, why you did what you did, maybe even write an interpretation within your code so that you can have an idea of what's going on. When you come back later, your future self will thank your past self for having helped yourself understand what was going on with the code at that time. All right, another thing to orient to that I did not go into before we get into the tutorial is to run code in R. You have a couple different options. One, you can use point and click, where this is some live code here, 2 + 3. You can highlight it or simply put your cursor on that line, either one, and click this run button in the upper corner here. You'll see it immediately evaluated here. 2 + 3 = 5. You can do it just by your cursor. 2 + 3 = 5. It had this because I commented that out, but it'll include that because it runs the entire line. What I like to do is push Control and Enter. It's much easier. It keeps me from having to use my mouse. So you can choose one of those other ways to run code from this screen here. If you were to run code directly from the console, you put 2 + 3, you just hit Enter. You don't have to do the Control and Enter. But if you do it from the source pane here, you have to press Control and Enter. All right. So let's get into some basic functions of R. Essentially, a lot of these are just basic operators. Some of them might be intuitive. You might already kind of expect that if you want to do an addition in R, you would use a plus sign. But I'm going to go through each of these just so to make sure you have a base understanding of what functions may be useful to you, how to use them before you go in and start coding up your own analyses. So you can use R like a calculator, but it would be kind of like using your private jet to go down the street to your friend's house. It can do a lot more. It actually has a much more you can do with it. The calculator on your computer app that comes with your computer would be fine for doing basic calculations. Is that if you want to use R just for adding your tip calculator or something like that, you can if you want, but it can do much more. But your basic operators are still going to be the same. You're going to use these for more complicated analyses as well. So if you want to do addition, you would use the plus sign. Pretty easy. You already ran that one. Subtraction, minus sign. Multiplication, you'd use the star sign. 2 × 3 = 6. Checks out. / for division. And if you want to take something to the power of something else, to exponentiate it, you could either use a caret, which is the upward triangle symbol on your computer, or you can use a double star sign. Either one, those are equivalent commands. I want to mention the order of operations within R as well. This is where your middle school or maybe grade school education in algebra comes into play. Is, if you remember, take care of multiplication, division first, then take care of your addition, subtraction from left to right. R does that already automatically. So it will take care of this 5 to the power of 2, 4 × 2, and then subtract them. Does that for you already. So just so you're aware of that. And this one left to right, 6 + 5 - 1, that should be 10. Yep. And I wrote this here, I'll be quite honest, I think maybe I just wanted to show you can take something to the negative power or something. I don't know what this was for, but I'm just going to run that for you. All right. So despite the fact that we know we have certain orders of operations here, you can help yourself, your future self, look at your code, or somebody else who looks at your code by helping create more clarity with your code. And here's an example here. Now this is the exact same line of code as was up here, only now we have parentheses. And when you do parentheses, just like you do in your calculator, it says take care of this first, take care of this first, and then take care of what's outside the parentheses. You don't need to do this, R already knows, but you may prefer to look at this very quickly versus this. This just might be an easier, more intuitive way to look at your code. But there are instances where parentheses are important. So here's an example of 5 plus 4 to the second power and 5 plus 4 to the second power. Or, let me say that again. 5 plus 4 to the second power, 5 plus 4 to the second power. So here we're just taking 5 plus 16. Yep, and then this is 9 to the second power should be 81. Yep. So just be aware of where you're placing your parentheses. Make sure you're telling R to do what it wants to do, what you want it to do. As someone who taught me always said, computer programming is really stupid. You're the smart one. You have to tell it what to do. Another example of code clarity. So this is fine. This code here is perfectly fine. It might be a little weird looking at first. It's -2 minus -4. Okay, it'll run fine. R knows what it's saying. But you, on the other hand, might rather see these spaces to help yourself look at it visually. So you get the same answer, but this is just a push towards or a advocation for code clarity. You may want to take the next step, which is something I like to do. I usually take my negative numbers and place them in parentheses, just so there's added clarity. Just some things to think about as you're using R to make your future self a little more happier and greater ease of use as you're writing up your code. Okay, and for added clarity, sometimes you want to include words with your numbers that you're presenting or your analyses or your results. And you can do that. We'll get a little bit more into functions later by using a paste function where we paste a string, a number, a string, and a number. Here we're pasting, I like the number 5 and 4, although I guess that should be an S there, numbers, it's more than one. And it'll print out just as one string. String meaning just a sentence, like words. You can also add mathematical functions. So we'll do the same thing, but this time 5 times 4. And it'll pop out with 20. Yep, it did it for us. So that could also help make your code a little more clear. All right, is there any questions so far? Keeps going. Okay. All right. Now, a big part of R and helping you when you start thinking about developing data structures that you're going to do your analyses with, or keeping record of your patients and certain variables that are important to you, is this idea of creating a vector. So often you don't just want to look at number 5 and number 4 like we have been so far, but rather a string of numbers for either for one participant or maybe a list of numbers for representing each individual participant. In R, we call those vectors. And here we're just going to show how to make vectors before, without making an object out of them, just showing how a vector is created. And you have a lot of different ways you can do this. So one way is to create your list here, whatever numbers that you want, add parentheses around them, and add a C to the front, which means to concatenate or combine those items. So we'll run this, and you'll note that there is a list of 1, 2, 3, 4. You could also tell R to make a list of 1 through 4, this colon means through, so 1 through 4. And you get the exact same thing. It's a sequence. Reverse order these. You can go from negative to positive. You can tell the entire list to be negative. This is one way to do so, or I could write negative in front of each of those. Either way, it would work. And we can also use the sequence command, which gives us some more options of how we look at a list of numbers. So we can do 1, 4 sequence, 1, 4. We get the same thing that we were above. We can also go from 2 to 8 and specify the interval by 2. So we should have 4, 6, 2, 4, 6, 8. Yep. We could do non-integer sequences, and these are your decimal points, right? These aren't your whole numbers. These are a sequence by 10th of a point here is what we're doing. So 0 through 1 by 10th of a point. Now we have our list there. Or we specify the length, number of elements that should be between those 2 points. So this is the exact same answer because we have 11 items at tenths of a point between 0 and 1 because it does include the 0 in R. And just another example, 0 to 5 should be every half point. Yep, 0.5, 0.1. So this is just get a sense for, we're creating lists right now, creating these vectors, and you can insert whatever variable is most important for you or whatever values are most important for you and whatever you do in your studies. And after we've created these vectors, we can do arithmetic on these vectors versus just the 5 times 4. We can do arithmetic on the entire vector that we created. Here's our trusty 1, 2, 3, 4 vector that we had before, and we're going to divide that by 2. Now this is, unless you've used other languages where it doesn't do this for you already, it might not seem very cool, but this is actually very cool and helpful. And that instead of taking the sum of that vector and divided by 2, it'll divide 2 by each item in that vector. So we get a list of, 1 divided by 2, 0.5, 1, 0.5, and 2. It takes each item and divides it by that. You can also do this with 2 vectors. So this time we're going to take 1, 2, 3, 4 by 4, 3, 2, 1, dividing the middle, and it'll line up each item in that list and divide it by its corresponding element. So 1 divided by 4 here, 0.25, that matches. 2 divided by 3, 1/6, that matches, etc. So it'll follow those, follow the progression as you would expect. You can, however, take, if you want the mean, say, of a vector, you could use the sum function. And we'll get more into functions. I'll have a list of functions for you so that these aren't, just not, there's a lot of functions you can use. I hope to have a list for you to get you started. There's many that you can use when you download other packages and things. But in this case, we're just going to look at the sum of this vector here we created and divide it by the number of elements, which is 4. So we're going to get the mean or the average. You could write it that way, or you could use just a function that does that for you already, which is the mean function on this vector we have here. We concatenated this vector, same thing. We should get the exact same answer. Yeah. You can divide uneven vectors together, but it's helpful if they match up, unless you intend them to not match up. So in this case, it's going to take 1 divided by 4, 2 divided by 3, and then it's going to take 3 divided by 4, and then 3 divided by 4. So it's going to follow the list and match them up accordingly. 5, 5, 7, 7. That makes sense. Oh, I was saying divide. I'm going to add. We're adding here, not dividing. But if you do an uneven list, it will do the math for you, but it will also produce an error telling you, hey, I'm not sure if you meant to do this or not. So the warning message, longer object length is not a multiple of the shorter object length. So it's just saying that these are off. And what this did is it went through the list here, 1 plus 4, 2 plus 3, 3 plus 2, and then 4 plus 4. And it had these 2 other items in this vector left over. So it's just letting you know that. If you meant to do that, fine. But if not, it's letting you know. And if you ever get an error like this, you don't know what it is. We'll talk about some helper functions here in a minute, but you can simply just copy and paste directly from R, paste it into your web browser, and I guarantee that somebody else has come across it before and will explain it to you. And if not, you can always post a question as well on one of those stats boards that we were talking about earlier. Okay. Now the fun stuff. We're going to take those vectors and we're going to place them into objects. So instead of having to write this, our fun concatenate 1, 2, 3, 4, like we had been, we can just assign it to a vector X. And we can just refer to X from now on, and R will know, well, you're talking about 1, 2, 3, 4. And the way we do this is we say the item, whatever we want. We could type our name here. We could type our cat's name. We could type cartwheel, whatever you want. I'm using X because it's easy. And we use this arrow sign saying, I'm going to assign what's over on the right-hand side to this. And we have our fun list here, concatenated 1, 2, 3, 4. You run that, it just says, hey, I ran that. And now when we refer to X, we have our fun list, 1, 2, 3, 4. We refer to it again, same thing. So now R always knows that X is 1, 2, 3, 4 as we want. You can do the same sort of arithmetic that we did with the vectors above without doing the object, but here with the object. Same response we had above. Our 1, 2, 3, 4 is divided by 2. Checks out, divides each item on that list that we're referring to. And I want to show you a trick here. If you instead of wanting to assign something to X and then print X by typing it below, you just want to see it even though you signed it, you can add an extra parentheses around that object in order to print it out automatically. Here's another function, square root. We're going to take the square root of X that we created, and we're going to assign that using the arrow here to Y. So now when we refer to Y, it's going to be the square root of X. And we run this, and it's going to print it out automatically because we have those added parentheses on the outside that aren't necessary. You can choose to do it or not, but it's helpful to just look at it right away. So now we have this list of the square root of X assigned to Y and X. And you can take these two vectors and you can do arithmetic with those. So multiplication, X times Y, X plus Y. You can see it lines up just as we did above, as I showed you up here. Just like we were adding two lists, it's adding X and Y, right? Only we can refer them as X and Y versus having to write out the concatenated list every single time. Right. You also do multiplication outside of the object and assign it to an object. So here we're taking 5 times 4 to A, which would be 20, and we're assigning 5 plus 4 to B, which would be 9. And we can do our sentences we were before just by referring to those objects, A and B, and print that out for code clarity so we know what we're talking about here. Okay. Now that we know about objects, this is good to talk a little bit more about functions and in depth. And when you get into a space where you want to use a function, you don't know what goes into it, there's many helping functions within R that'll help you understand what you need to do to run it appropriately. All right. So we're going to use, we already did this mean before of this concatenated list. I could have assigned this to X and done this, but here I'm just showing the concatenated list here in mean. And I'm doing X here. I guess I have the X right below. We could do either of these. SD stands for standard deviation of a vector. We do the concatenated list, or we could do the object that we created of Y. See a standard deviation of that. I do want to note that these objects are still the ones we created above. They're not the same as these concatenated lists that we have here. So we do expect different answers. Or do the median. So these would be your descriptive statistics for a continuous variable that you may want, right? And then we did the square root above, and this is a square root function, sqrt. But there's a lot of times where we have a function, maybe we know it, but we forget what needs to go in that function. It's hard to know that y would work in the standard deviation function. You might want to check or know if there's additional arguments that you may need. So luckily, R already has a function to help you do that. It's called args. It's pretty intuitive, just args, and then you put the function that you want. So we're going with the arguments for square root. This one isn't very exciting. It's just an x value, which means some sort of a list of variables, right? Or an individual variable in this case. You do the args for mean. This one's a little bit more exciting. We have some additional stuff, but it might be more confusing to you. So we have our function, which is mean. We have x, just like we had above. So it's a list of items. We have this elusive ... Okay, that just tells us that there's something more we can put in there. It's not telling us what that is yet. So we're going to do a little more investigation. We use the help function for mean. And this is where the helper window comes in, right here. You can expand this if you want. But it tells you what this is. It just tells you the description of it, gives you the usage. We already got this from the args. And this gives you a little more information though, about what that might be. So we have an argument of x, like we had above. We can choose to trim it. Now this says trim equals 0, because that's telling us that's the default. It doesn't have a trimmed mean automatically. You would have to tell it trim equals 10 or something like that. You can trim 10% of the mean. And this na.rm is a function. If you ever have questions about this too, you can just look down here. This gives you more information about what the argument is. It just indicates what to do with missing values. So in R, we always code missing values as na. And if you have missing values, you can choose to remove them or keep them. In this sense, the default is to not do anything with them, so it's false. And you can look down here. There's also reference to where the code for, or the idea for the code for the function came from. That gives you some ideas of some other functions that might be related. And it gives you an example right here. You can copy and paste this into your source window here or in your console, and it'll run it, and you could get an idea for the function of it. Now you don't need to write. If you don't want to write help parentheses mean, you can just do question mark mean. You're gonna have to trust me. This popped up here. It's the same thing, so it didn't show anything. But let's do square root. And you notice that we have the square root function here, and it tells you more information about the square root function, just like did with the mean. So it pops up here in the helper window. You can also search for help within R. And it comes up with a bunch of topics here. We searched for mean. We have a bunch of different packages that have anything related to mean. So here's the Broom package with something called k-means, which is a way of clustering. em-means is a package. So everything related to mean, if anything has anything to do with means, you can look up here and see if there's a different sort of a mean function that you want. You can also search online, straight from R, do an R site search, mean and functions, and this should pop up here, a list of different functions related to mean. So here's our favorite mean we've already been using. We can, some other mean objects here or functions here that you can look up and get more information on if you'd like. So there's already a lot of help you can get from R if you ever are confused, not know what's going on. Obviously a Google search or whatever your web browser of choice search could use to look up as well. It's always very helpful, but there's already a lot of stuff within R to help get you going. or as if there's ever a question. All right, one other thing I want to cover, I definitely want to make sure we cover, is this idea of indexing. So before we created this 1, 2, 3, 4 list, or here's 1, 2, 3, 4, 5, which is great. And maybe we want that entire list, but sometimes we only want one item from that list. And that might represent just an item within the list of numbers. It might represent one participant, or it might be one value from a participant within that list. And so to extract that, I'm going to show you how to do that. We use this bracketing method. And I'm just going to take this function rnorm, which is just a random normal distribution. I'm going to take 100 participants from them and assign it to X. So we're not going to have our 1, 2, 3, 4 anymore. We're going to have 100 random items from random normal. And you'll notice it pop up here. Here's our 100 items that popped up. Now that's nothing really that important here. What I want to demonstrate is that I can take the 12th item from this list, which should be around here somewhere. Let's see what pops up. 0.697. It's like right here. Yep, got the 12th item right there. Cool. Or we take the second item, the third item. And I just want to get across to you that what you do is you take the list, the object you created, right? Whatever it is, use this bracketing method, and you put the item number that you want in there. And we also get to use some stuff that we already learned before, such as if we want to take the 6th through 15th element on that list, or 6 through 12, we have 12 here, 15. Could be 12, 15, whatever you'd like. We take the object here, we bracket it, we're telling R we want only a subset of this list here, and we just want the items 16 through 15. So we take the 16th through 15th element, and there you go. You can also take, sometimes you don't want items that are directly next to each other. You want specific values from that list that are separate from each other. So in this case, we're going to take 1, 2, 3, 4. Use our concatenated list like we had used before, 1, 3, and 5, sorry. We're going to use brackets around that because we're going to take a portion of this X variable here. We're going to take the 1st, 3rd, and 5th elements, which get 3 values, 1st, 3rd, and 5th elements. You can also index by subtracting items. So if I only want the first 10, I could say that I don't want, so what I'm doing here is I'm bracketing X again, using the minus sign, saying that I do not want items 11 through 10, which only it would be left as items 1 through 10. I could do that way, and it would keep me with just the first 10 items like I wanted. Or I could just select the first 10 items, again, X, for bracketing, items 1 through 10, I should get the exact same thing. Yes, it looks the same to me. Okay. All right, we have 20 minutes left. Is there any questions I can answer about that so far? We good? Okay. I sectioned this portion off here for if we have time. I do, since we have 20 minutes left, I'm gonna just go through this, but feel free to go through this later if you're interested. This first part is just you can index as well by trues and falses versus selecting certain items. And here's a list of logical operators that you can do to, like, if you want to ask R, does 1 equal 2? Use this double equal sign, and it's going to say false. And here's the number of different logical operators. They'll be useful to you as you're writing longer lines of code. So I just want to make you aware of those. But something I do want to get into, and I am going to go through this rather quickly. If you have a question, please stop me. Feel free to ask. But I do just want to show you what it might look like to import a data set, work with that data set a little bit, do a very basic ANOVA and some basic graphics, just to get a sense for how it could be useful for you if you wanted to, say, look at the mean differences between a patient and control group or something like that. All right. And I do have to cover a couple things to make sure that also some things going to be very important to you in the future is using R. And one of those is this idea of installing packages. We use lots of different packages in R. Like I said, there's over 10,000, and they help make your analyses easier. You're going to want to install them. It's a pretty easy command, pretty intuitive. You would just install .packages. Then you put the name of the package you want to install. You may have found this on the internet, or you can find it within R. And I'll show you that here. So if I did install packages, and I knew I wanted car data, I would just type car data, and it pops up here for me already. I might want car dates. I don't want car dates. I want car data, and it'll show up there for me. It helps make it easier for you, so you don't have to look it up all the time. But you would install this package just by running this, and it's going to take a minute. If you're following along with me, it's going to take a minute just to install it. It's maybe a couple seconds, not too long. But then after you install it, you're going to want to load that library. So you use the library command, car data. What that does is it puts it into your R session, so that if there's commands that you want to use from that function or from that package, you can just refer to those. It makes it very easy for you to run those. So we're going to go ahead and do that. So now you have access to anything that's within the car data package, and you can look that up online. You can also do the help function. Sorry, it's never good to live code. Sorry. Yeah, probably best to find it online. But searching here in the help function, it'll show it as well. I don't want to spend too much time doing that, but you can find it, trust me, if you look for it. So there's a number of different functions you can use. You can also just type in, if you were to type in car data, you see this car data, 2 colons, and it has a list of functions here that you can use from car data. And let's say I want to use this Adler, but I don't know if I want to use it. Just highlight it. It has some information here. It might be a little small for you. It's just push F1 and it'll pop up over here and tell you everything about that function. So it's pretty intuitive. It tries to be as helpful as possible. And documentation is, I've yet to find a situation where it's not been well enough that I could figure it out. So, so now we can just use whatever function that we want from car data. And the one we want to use is Duncan. We're going to pull this Duncan, and Duncan is a data set. We're going to pull that. You do not need to do this. As I just demonstrated above, I had car data : : that's a way to refer to a package without using the library function. You could just use Duncan since we already loaded it. I just like to make sure I know where that function is coming from. So I do this. This is maybe a bit of it's hard to go through somebody else's code and go back and know if they have something written where it came from. So that's just something I like to do. You don't need it. You can delete this if you want and just run Duncan since you're able to the library. It's up to you. And we're going to assign it, like we did above, to what we call Duncan data. So we can refer to it later. Now we'll have this data set. And we just ran it. So it assigned it to Duncan data. In this instance, we're downloading a preloaded data set. I do want to give you an example of here in this coded section here. If you had this data set and then say a CSV file from Excel file or a CSV file, you could download it this way. You would use a function called read CSV, have a file name, and assign it to that object. So it would be a very similar process if you're downloading your own data. And here's an example of how you would do that. You just need to make sure you specify exactly where on your computer that file is. And this is what the file structure might look like. C, username, whatever the file path is, and then the function here. And make sure it's in parentheses, or not parentheses, and quotations. Since this is a data set that's already available, or that's already on this package car data, it has a help function to help us describe what this data set is. You might have a code book for your data. You would want to look at that, but this is where the code book would be since this is already on R. We can just look at that. and it pops up here. It tells us about different variables within it. I went ahead and typed this out for us. And so we have 4 types of variables. 1 is the type of occupation. 2, we have income. 3, we have education. And 4, we have prestige of their job. It's a data set looking at different types of occupation, their income, education, and the prestige of that job. And you can look at associations between those. Since we have that data down, we want to look at it. You can do that simply by typing the name of the vector or the object that we created, right, of Duncan data. We can just do that. And now we have this data frame here we can just look at. So we have type, income, education, prestige, and looks good. We could use a view function and it'll pop up like a table over here on the left-hand side. And you can adjust it by, say if we want the max or min to be, we can order it however we want here by clicking on these tabs. Just kind of get a look at it. We can just look at the first 5 items using the head command, or we can use the tail command to look at the last 5. As you can see here, the structure of the data. Now this might, if you're not used to this, this might not look very useful. Once you get used to it, you'll find out that it is. What this tells us is that there's 45 observations. I mean, there's 45 participants on the left-hand side. There's 4 variables. There's 4 columns. We have a factor variable with 3 levels, an interval, and 3 interval variables, meaning these are numeric variables. They're continuous of income, education, prestige. Okay. And you can also look at the dimensions as well using the dim command. And that's the same thing as here, 45 observations by 4 variables. That's the dimensions of the data frame, right? Now we can look at some descriptives, kind of low on time. Okay. We're gonna use the psych package. We're gonna do the same stuff as we did above. Something to point out here is that we're gonna do the Duncan data again. We're gonna subset this data frame. We're gonna take the columns. So this would be where the rows would be at. We want to keep all the rows so we don't have anything there. So nothing there, comma, and then we're gonna take columns 2 through 4, because if you remember, this is column 2, 3, and 4. These are continuous variables. We don't want the mean and standard deviation for the type of job. This is just a string variable. It's not going to work. So we're going to take those columns. We're going to look at the descriptive statistics using the psych package. And see here, income, education, prestige. We have the mean, standard deviation, median, minimum, maximum, skewness, kurtosis, all the stuff you would want to know for that. Now, something we do want to know about the categorical variable we have is the counts of each. You notice here we have 21 in the BC, which stands for blue collar in this data set. For professionals, we have 18 of those, and we have WC, meaning white collar. We have 6 of those in this data set. Okay. So just throw in a couple of plots to show you how we can visualize our data. I'm going to make sure this window's open. And we're going to use the car package here and use their function scatterplot. I find it very helpful and really easy to use. Now you note that this popped up with attaching package car, following object is mask, logit, logit. This isn't an error. This is just letting you know that there's a common function between these 2 packages, and it's saying, hey, I'm not going to let this package use this because it's for this package. It's nothing to be concerned about, although it is in red. It is kind of concerning when it pops up, but it's just letting you know something. And we're going to do a scatter plot of income being predicted by education, and we're specifying the data, Duncan data set. And I guess I would assume that as education increases, income increases. Let's see if that's true. You see the plot here, down here. You can expand this if you want. We have income on the y-axis as we anticipated, because that was on the left-hand side here. Education on the x-axis, which is right here. And we do see this upward trend. Now this function does some cool things here. It fits a linear line, imposing linear associations. It also fits a a lowest line, meaning it doesn't impose necessary strict ideas of linearity. It looks fairly linear, even though it doesn't impose that. So that's a good sign. It shows us the minimum maximum values across that line. And then this is the distribution on these sides. Gives you a lot of good information. And generally it looks like, as we would expect, that as education increases, income increases. We'll do the same thing, but with prestige, this time predicting income. I assume prestige or income. Yes, that's the same. And then here's education and prestige. As you have more education, you would have more prestige. That would make sense. Yes, so we're seeing a very upward trend in all of these. Everything's lining up as we expect. But it may be that these groupings that we have of blue collar, professional, and working or white collar might have important information about our data too. So we're going to run an ANOVA here with the type of job predicting income. And we're assigning it to this object, inc, that will allow us to do some things with it, including look at the results using the summary command. And if you're a fan of statistical significance, you'll notice that this is pretty significant. We have a value that's 3 stars here, meaning it's well below our 0.001. So our standard being 0.05, something's less than that. Typically, it's considered significant. So we have something significant here. But as you know, with an ANOVA, it doesn't tell us what is significant within that, just an omnibus test. So we want to look at the individual associations. So we're going to run this 2-key post hoc test. And we see that professional to blue collar, there is a pretty large difference, and it is significant here. From working or white collar to blue collar, it's different, and it's significant as well. But from white collar to professional, it's pretty small and it's not significant. So if we want to view that, we'll use the box plot command. And we'll see that blue collar, pretty low here on income. Professional is pretty high, and working class overlaps a lot with professional. I don't know what the distinction is between those. I assume that they're pretty similar in a lot of ways. So that makes sense. And we're seeing exactly that these two are different and these two are different, but these two aren't necessarily different. And if you want to get fancy with it, we can plot continuous associations. This is just a demonstration at this point of something you do with a package called ggplot. And this is plotting the continuous associations between education and income for these different groupings. So our blue collar goes up, our professional goes up, but working class goes down as education increases. And I don't know how much I trust that, because as you recall, we only have like 6 participants within the white collar group. So I don't know, but that's a way to visualize your results, and hopefully it could be something exciting you want to put in an article you might publish. All right. All right, so wrapping up on time here, but I do want to just give you some continued resources to help keep you going in R, learning a little more. First, there are some free code practice websites online. Now, you don't need to write these down. You can either just search for the names of these, or you can click on the slides that I gave you. The links are available there. But one is Software Carpentry. There's some online coding practices that you can do directly online, as well as free code camp. It's really good to have practice at doing code in different ways. That's really helpful to ingrain your learning. If you want a more comprehensive resource, there's this free book, R for Data Science by Hadley Wickham. It's free online. You can pay for it on Amazon if you want, but it's free online. So you can go to this link or look up R for Data Science, and you'll find it there as well. So I just want to make you aware, if this code seemed to be daunting, you can get started in R with a point and click interface, much like SPSS, something called R Commander. Just like we did with the install.packages command, you would just do install.packages R Commander. And there's plenty of documentation online. You can click on this link on my slides, or just look up R Commander, and you'll find a lot of documentation about making sure you download it properly, as well as how to use it. It's pretty easy to install. With Macs, there's an added step, just want to make you aware of. You have to download something called Xquartz, but if using a Windows machine like mine, you can download it very easily and use it right out of the box. Okay, and that is it.
Well, thank you, Drew.
Thank you so much.
My sense is there's so much potentially to learn about using these packages, but that's a great beginning and overview. I think we've had a few residents who are interested in considering R and learning more about it. So thank you for coming and doing that. Do you guys have any questions for Drew? I know we only have 2 minutes.
I was just going to ask quickly, is this psych package one that you would recommend, or like, is that like what you typically use?
Yeah, the psych package is a core package for me and many people who I've worked with who've used R. It's a lot of helpful functions beyond just, I use it mainly for descriptives, but you can do other things like different clustering analysis, independent components analyses, and different, like, making sure your measurements are reliable and things like that. It's a very, very helpful package. I would highly recommend it. Yeah.
Okay, great. Thank you.
Yeah.
Okay, very good. We will post this recording for our residents. And I think, this is a sort of whirlwind tour to get your feet wet.
Yes.
And there may be a small group who over time start using R. And if that's the case, I may invite you to do another presentation that we record for them. But thanks again. And really appreciate you taking the time to do this.